work a lot in composite strengthening systems. Could you tell our listeners a little bit about that and explain how that fits into the structural engineering industry?
Yeah, so composite strengthening systems, whether or not it's an industry term, it's the term we use at Simpson Strong-Tie, or FRP, which is fiber reinforced polymer, and FRCM, which is fabric reinforced cementitious matrix. And those are basically just externally bonded reinforcement systems that use either carbon fiber or glass to create strength and stiffness, or epoxy or cement-like cementitious matrix to create a bond with the initial substrate.
Composite strengthening systems have revolutionized the field of modern structural engineering by offering unparalleled benefits in terms of strength, durability, and sustainability. The ability to restore and upgrade existing structures rather than opting for costly replacements has made these systems an attractive solution for architects, engineers, and builders worldwide. In today's episode, we'll dive into the game-changing benefits of this innovative technology and explore how it's transforming the way we design and build structures. So today we have a special announcement with our guest, Alex Daddow. He's a PE and a CDT, Senior Strengthening Solutions Engineer at Simpson Strong-Tie. He's going to be joining the Structural Engineering channel as our new co-host. I've worked with Alex for the last 5+ years, and I'm so excited to have him join Matt as the new co-host. I'm looking forward to seeing where the two of you can take this podcast. So join us today as we get to know Alex, his journey from traditional design work to an industry-facing role, his expertise in composite strengthening systems, and his vision for the future of structural engineering. I'm your co-host, Rachel Holland.
And I'm your co-host, Matt Picardle, and this is the Structural Engineering Channel. Alex, thanks so much for joining us. Can you tell us a little bit about yourself and what led you to pursue a career in structural engineering?
Sure, yeah. For one, my name's Alex Daddow, and I grew up in a pretty small town, went to the, grammar school, like preschool through high school within 1 mile of where I actually lived. And I was always good at math and drawing, really liked my high school drafting class, so thought when I was applying to Cal Poly, which is where I wanted to go, that's where my parents met, great school, what major fits in with math and drawing? And then I saw the architectural engineering program, did a little bit of research on it, and realized that it was really, really good program, and I'd be lucky to get into. So yeah, I made that the goal, and the longer story, but I was waitlisted and ended up getting through all that and getting accepted. And then once I hit the ground in architectural engineering, I really enjoyed it. And I really like the engineering aspects of structural engineering, but I also really like the business aspects of structural engineering. And I've always been more social, so I didn't quite always enjoy being at my desk. Yeah.
So another Cal Poly Archie. Well, it's kind of fun, actually. All three of us are Cal Poly grads, right? 2 Mustangs, and then Matt, what's the Pomona one? A Bronco. Okay,
Broncos.
So we're all horses. But okay, so you just mentioned you realized you didn't want to be at your desk all the time, and so how finding out that about yourself, how did that kind of shape your career?
Yeah, I mean, it's this pretty stark reality to face that you went into the line of work that kind of requires you to be at a desk, and then realize that you don't actually enjoy being at that desk. And I had to really think about it because I do like engineering, and that's where my skill set is. So it's like, oh, I can go into sales, but then I kind of don't get to build off of what I did before, maybe a little bit. I mean, you can draw that relationship. Really trying to pay attention to myself more and see what aspects of my actual structural consulting job did I like. And I liked site visits. I like going to meet with architects, pretty much everything but being at my desk during the day was an important thing to notice. So I basically realized that growing up on the farm, I like being outside during the day, but I don't actually mind being on a computer at night or at my desk. I did that my whole life. And I just wanted to try to find a role that still did engineering, but then during the daylight hours, I could go out and just feel more like me, which was somebody that talks to people and collaborates with people and not so much crunching numbers on a computer. happy to do that in the mornings at night, though. So I think I kind of found a better
So
fit.
on that same note, you did consulting work right out of school. And then how has your career path changed? Like where are you at now for the listeners that don't know you? Obviously, I know you.
Yeah.
Mm.
So yeah, I was a structural consulting engineer for like 7 years straight out of Cal Poly. Kind of worked up and down the coast of San Luis Obispo to Santa Rosa, down to LA. It was going well. I was doing fine, but not really that happy at the actual desk. So this is actually my second job working for Simpson Strong Time in my career path, and actually applied to get away from my desk basically. So I was going for a sales position. I had one interview with the sales manager and then a few other interviews that were all engineers. So at the time I didn't realize it, but I think once Simpson realized I was an engineer, they expertly guided me into the engineering role that I'm in now. And it fits what I like very well. I always liked old buildings, always liked the engineering aspect of the job. And I get to get out and meet with customers and have that human interaction, do flex some of my business skills, and really kind of just combines everything I like from the engineering side without completely exiting the engineering world, where I still am at my desk at nights and in the mornings crunching through plans and calculations, just like a design engineer. But I get a lot of other stuff in the mix, public speaking and things like that. So my actual role, I think that was the real question, is senior strengthening solutions engineer. So I essentially travel around, teach people in the industry what you can do with composite strengthening systems. It's FRP and FRCM. And if they have a project, then I help them, anywhere from design through construction.
I was just going to say, I love hearing this because I think a lot of our audience is younger engineers, and they are always interested in hearing what other routes of structural engineering are even available to them as a structural engineer, like how to stay in the field, but maybe try something a little different. So I think that's a really awesome example of it. And then I think also you made a really good decision because you're excelling in this role. And, the first year at Simpson, you were awarded with the Excellence in Engineering Award, which is amazing. And then also on top of that from ICRI, which is ICRI, they awarded you with that 40 under 40 award, talking about how you're making a big impact on in your career. So that's pretty awesome that you made that switch.
Yeah. Yeah, thank you. And it feels good, right? Because you get into something that you're good at, which was engineering to begin with. I always knew math and drawing, I'm going to be a good engineer. But then you start to feel like you're not excelling because you're not getting the satisfaction that you want. So switching into a role that kind of fits my personality better, but kept the engineering, I don't think I would have gotten awards if I didn't actually find a path that, fit me a lot better. And then I try much harder and I'm happier in general and I do better work. Yeah.
That's great. And I think it also shows that in structural engineering, there's different paths for all different sorts of personalities, or even if it evolves, right? Even for me, or I did a lot of new building designs. Now I'm doing more existing building designs, finding new challenges in that. And kind of related to that, you work a lot in composite strengthening systems. Could you tell our listeners a little bit about that and explain how that fits into the structural engineering industry?
Yeah, yeah. So composite strengthening systems, whether or not it's an industry term, it's the term we use at Simpson Strong Tie for FRP, which is fiber reinforced polymer, and FRCM, which is fabric reinforced cementitious matrix. And those are basically just externally bonded reinforcement systems that use either carbon fiber or glass to create strength and stiffness, or epoxy or cement like cementitious matrix to create a bond with the initial substrate. So it's a little weird because the materials are composites, they're carbon and something else. And then they also work in composite with the parent substrate. So we are actually applying reinforcement just on the outside and getting it to work in composite, just like you would a steel pan deck with a steel beam, concrete filled steel pan deck and a steel beam. It is a composite design, but with a composite material. And yeah, it's just like if you're looking at concrete block or brick and you wish there was more steel in it, then you could probably look at one of the composite systems and it's likely to meet the goal you're looking for. And that's what my job is, to help you figure that out.
And is it essentially, I'm still new to it and learning about it. Is it essentially just gluing on fibers, let's say it's a concrete wall or a brick wall, are you essentially just gluing on fibers, kind of like duct tape to strengthen it, or what's the basics of that?
Yeah, I've heard people call FRP structural duct tape, which we try to downplay a little bit because it's much better than duct tape would be. And then also our FRCM system, I've heard people call that, oh, it's kind of like structural stucco. And I mean, they kind of are, and that's an easy way to think of them. But FRP's better way to think of it is you're suturing a building back together. So in the early days of FRP in the States, yeah, we really did just kind of glue things onto the slab or the wall, whatever we're trying to reinforce. And that works, and that's fairly well understood. The problem is, as we started testing bigger and bigger scale structures, we realized, oh, it works to a degree. Well, we get to one layer of a 44-ounce fabric, it works pretty well with those just straight bond equations. But if you make it a heavier layup, like 4 layers of 44-ounce fabric, your concrete doesn't get any stronger, and it's what's creating that shear transfer. So at a certain point, your FRP is so stiff and strong that the concrete itself fails underneath it, and you can't get the load transfer. So yeah, back in the day, it was, let's glue it down. That'll make things stronger. And then as we studied it more and more, we realized, well, we still glue it down, but we're going to need to use FRP anchors to actually detail this out. So it's kind of like, oh, we sized the number 5. Now, where does that number 5 need to be bent in order for it to actually perform the way we calculated it? And that's where we're going with FRP. Yeah.
So
yes.
From your experience, Alex, besides like referring to it as duct tape and all the other things, what are some of the biggest misconceptions that engineers have about strengthening solutions?
Yeah. Well, I mean, the big one that seems to pop up the most often is that you can just glue it down and it'll function. It has kind of an intricate process of actual good installation. You got to prep the concrete, fix any issues with concrete or masonry, cracks, falls, all that kind of stuff, and then properly install it with full saturation of the fibers. That's pretty complicated on its own. And then if you just roll it out and lay it up on something, our testing that we've done at Simpson kind of shows that, yeah, that'll get you pretty close. But if you have a very thick layup, you actually need to take the extra step and anchor things off, detail them correctly to get the performance that is predicted. So that's one of the biggest misconceptions, is it's some sort of magic carpet that you can apply to anything and make it work. That's not how it works. We help you with that. There's actually limitations to what you can do with it in gravity that are fairly stringent, but that doesn't mean I don't want people to call me. We'll just design a different solution if carbon doesn't work. And then when you go to lateral situations, you can't over reinforce with it. So sometimes an engineer will ask me, we need the capacity of this pier to be X number of kips load. And we go look at the actual dimensions of the pier and the compressive strength. And that's like 15 root F prime C. And we're actually still limited to the 8 or 10, depending on where you are in ACI. So we can't over reinforce with it either. You'll have to stay within those acceptable code limits. So that's one. The other one is, a lot of people think it's really expensive. And if you look at 1-to-1 by area, FRP, FRCM are going to be pretty similar to, let's say, 6 inches of shotcrete on a wall. So they look kind of expensive when you think, well, I get 6 inches of shotcrete and a rebar cage for one price, and then I get about a credit card thickness carbon for the other price. But where the actual savings is in the actual work that surrounds those. 6 inches of shotcrete will often require new foundation work to support the new weight. It'll often require new diaphragm connections to support the out-of-plane weight of that 6 inches of shotcrete. And if we use one of the lighter composite systems, we can usually get away from the additional foundation and diaphragm work, and we're actually saving 6 inches of architecture along the way. Which that makes big impact with owners and architects.
Yeah, I was going to say, I think the square footage alone is the space saver, like with money stuff, right?
Yes. But yeah, the big one is it can't fix everything. It is not a magical substance. Make sure you work with somebody that understands it and has a lot of testing, and everything will go great, but don't expect it to change the world immediately. Yeah.
Yeah. So what type of structures is it mainly used for? Seismic retrofits, light gravity work? What are some typical types?
It's regionally kind of all over the place. We use FRP to fix large diameter pipes on the inside of them. If you're out in Montana, I get a lot of big, giant concrete silos that need strengthening. Maybe they want to cut a new door in it to help it clean out quicker, or just make sure it's ready for the next microburst of wind that's coming through. If we're down in LA, it's a lot of high schools and hospitals getting ready for SBC 4D work in the hospital realm. And then DSA's got quite a few retrofit requirements out there. Historic projects usually use composites because, again, we do tend to save architectural features a little bit better than some of the other strengthening methods out there. Non-ductile concrete is huge in Southern California, kind of all the way up to the Bay Area. But then if you were to go up to the Pacific Northwest, it's a lot of masonry retrofits, and they're starting to introduce URM mandates out there, but it's not mandated yet in Seattle or Portland. So you'll see some of that. If we go out into the Pacific, we see a lot of corrosion issues in infrastructure and military bases. Some bases even had concrete that was mixed with salt water. So people are using composites and repair materials kind of all over the board to save every type of structure. Again, if it's concrete, block, or brick, sometimes steel, sometimes wood, we can likely fix it, or at least give you good ideas on how to fix it. But yeah, it can be anything from, I did a cherry pit, like a cherry growing facility where they're processing cherries. And then I've also worked on the West Seattle Bridge. I've worked on the Dexter building in Seattle. Just kind of all over the board, anything that needs strength or repair.
Interesting. So you've definitely worked on a wide variety of projects. If you had to pick one, what would you say was maybe like the most challenging or rewarding project so far in your career? And then like, what did it teach you in terms of like strengthening solutions and, working with different stakeholders and things like that?
Yeah, the most challenging projects are usually ones where there are multiple stakeholders in the ownership, a peer reviewer working with the structural engineer, and then now they got us in the mix, and maybe we're under ICRI or the DSA. But the more authorities you have involved with a project, the more difficult. There was a project I was working on. It was a dam. We passed it through with the Army Corps engineers. They liked it quite a bit. And then they went to the next step, and somebody at the Department of Water needed to review it. They had looked at something that, like an engineering judgment we had made, and they said, unless it says on paper you can do that somewhere, we're not going to do it, even if your engineer enjoys. So that one just went away. No more FRP. But one of the more challenging projects I worked on, and again, I won't list names, but it was a university project, and it was kind of a sensitive university building where research was being done, and there was something happening in the building that had been ongoing for decades, and you could not touch that research project. None of the construction could affect it. If you did, it would possibly have to start all over, and there goes a couple decades of work. So we had to be really careful, and we needed to reinforce things that are built around this whole research project. So the diaphragm, the walls, collectors, all this kind of stuff. And you couldn't actually enter the room that it was in. So if it had slab and it had positive moment issues, normally we'd address that from the bottom, but we actually couldn't because we can't go in there. So we had to basically bring in not only Simpson engineers, but engineers from structural technologies who we partner with on some of our strengthening efforts, kind of combine resources. So we were doing the FRP fix in one place. We did a little bit of repair mortar in another place. They did some concrete member enlargement and some PT in another, and just combined all these different systems. And it's a university project too. So the way at least I work is everything I do is free in design. The only way that my company Simpson's going to make money is if somebody actually purchases our material. So we're going through the coordination effort with the engineer of record, his peer reviewer, the plan checker, the architect, the GC is already on board doing constructability review, and then you have our engineers and the structural technologies engineers, and all of that's got to coordinate together. And those are the challenging ones where there's no obvious solution. The problem's complicated and touchy, and then there's more and more people looking at it, and that makes it really interesting and really thorough, actually. It's like kind of like when you work on a DSA or OSHPD project in California. By the time that thing is through permit, you are good. You know you did a good job, and that is the way we're going to build this thing, and that's kind of how this project went too. You do a lot of study, a lot of effort, and here we are.
Yeah, existing projects. That's what I'm learning too. I'm working some on existing buildings, and it's a different set of problems. I think, at least for me, since I've worked on new buildings a lot, existing buildings have the things that you're saying, these complications that maybe you can't interfere because it's existing, it needs to run operational. What are some of the engineering solutions that the team can come up with that you wouldn't run into new building design? So that's pretty cool. I've been finding that really interesting too. And as and Alex, you're going to be the new co-host. What do you expecting? How are you feeling about it? And what are you looking forward to?
I'm looking forward to talking less because this one I have to talk a lot, and I want to be on your guys' seat. That sounds really nice. But no, I mean, when the notification went out and I heard that you were looking for a new host. I knew a little bit about the show, enough to know that it's definitely something that I wanted to get into, because the overall topic I'm fairly passionate about, and maybe it goes back to Cal Poly days where Ashraf Habibullah would come by and throw us parties and talk about this. But in general, structural engineers, we are very, very hardworking but underspoken people. So picking up an avenue to give engineers a bigger voice would be great. And then I particularly like the subject of giving young engineers new ideas on what they can do as structural engineers. That we need lots of design engineers. That is a great profession. If you're comfortable with it and you love doing it, I have nothing against you, but it was not going to work for me. And I almost left engineering entirely. So it's I guess I'm passionate about giving engineers ideas, what we can do, and getting us, to be more proud of ourselves, basically. So we should be. Yeah.
Yeah, absolutely. That's awesome. And what do you see about the future of composite strengthening, retrofitting solutions? Do you see advances that are probably going to take over? Is stuff going to get stronger? Are new solutions going to come in? What do you think?
Yeah, there are. And last year I was chair of our internal focus market committee that focuses on, all right, what are we going to do next in the strengthening market? And we have those for lots of things at Simpson, but really, I don't know where we're going to go, because I know where we've been. And after I put myself back 20 years, I don't think I would have predicted that we got here. But what I know is every bit of innovation that we make is an incremental change on something that was done before. So if we looked close enough, we could kind of tell that we know the composites are still going to be in the strengthening market. They have some issues around fire protection that I'm trying to address in ACI 562, and we're trying to address with new products. But essentially, it's going to continue to develop, and it's going to get more and more understood. And I think the next big step for the composites realm, at least FRP is the big one that everybody in the industry is turning on to more, is getting it into the code. So Gravity Code came out this year. 369 is going to have some seismic provisions in 2028. And all the different manufacturers are pushing through a HCI OSHPD design manual. So once those are codified, I think all of you are going to show us what we can do with it. Because right now we know what we do, we know what we would like to do, but once it's out in the hands of every structural engineer out there, I think we're going to really see what it can do. Yeah,
That'd be exciting to see how the designs really take off. So Alex, one thing that we always ask our guests as a final question is, what advice would you give to potentially a newer engineer or younger engineer looking to expand their career beyond that traditional role? And yeah, just like in general, based on the experience you've had thus far in your career thus far, what is like the best piece of advice you want to leave with our listeners?
Oh, ask a lot of questions, and don't be afraid to be wrong, especially within your own firm. Like you should feel comfortable asking your principal about anything, and hopefully you have the type of principal engineer that will help you with anything. But outside of that, pay attention. Pay attention to what opportunities come across your desk and what you like about them. Because you at some point are going to find yourself frustrated. I mean, it happens with everybody at work. And if it keeps happening, that's probably a good sign that maybe you need to look at a different role. If you've been frustrated for 4 months, doesn't mean get out of engineering, Alex. That's just where my head took me. It probably means you need to take a little bit shift in the career path and find a little bit better fit. Pay attention, protect yourself, celebrate yourself when you do good things, because we do really complicated, difficult work. And second I press print on a set of plans when I was consulting, oh, here's 5 more projects to work on. So take a beat, make sure you celebrate. And yeah, if you pay enough attention, you'll find the right direction for you. And it won't be anything anybody else tells you to do either. It's going to be something you figure out.
Yeah, everybody has their own individual path. Well, thank you so much, Alex, for sharing your insights and all of your expertise with us today. It's been a pleasure having you on the podcast, and I'm really excited for our listeners to get to know you better as you take on the role as the new co-host. And I am excited to hand it over to you.
Thank you. I appreciate the opportunity.
Looking forward to it, Alex. And as we welcome Alex to the show, we'll also take a moment to thank Rachel for all of her incredible contributions as she passes the mic to Alex. Rachel, it's been a pleasure having you on. Thank you so much for being a great co-host, all the ideas and guests that you've contributed. I know life gets busy, but I wish you the best, and we'll definitely miss you.
I have had such a great experience co-hosting the Structural Engineering Channel podcast. I've met some incredible people in this field, and I'm grateful for this opportunity. So thank you so much to the whole podcast team for helping me in this role, and also Matt, obviously, for being an incredible co-host. I really appreciate it.
Yeah, you'll definitely be missed. I hope you enjoyed the episode today. We'd love to hear your feedback, comments, and or questions. To leave them, please visit structuralengineeringchannel.com. There you'll find a summary of the key points discussed in today's episode, as well as links to any of the resources or websites mentioned during this episode. Don't forget to subscribe to Apple Podcasts, Spotify, or wherever you listen to your podcast. Until next time, we wish you the best in all of your structural engineering endeavors.